In the year 1927, there was a great unrest in the scientific community. The events that would unfold in the years to come would rock the very foundation of every scientist's dogmatic perspective. What is quantum mechanics? It's how quantum, small particles, interact with each other. Max Planck was the first scientist to introduce the quantum. He did this by studying how different wavelengths of light burned at varying intensities. The quantum came as such a surprise to every scientist that even Max Planck didn't believe it was an actual physical property, merely a mathematical way to calculate black body radiation. He also introduced the Planck constant, denoted by h, that shows how large or small the quantum is. Now the forward march into the mysterious world known as the quantum has fully begun. Many new concepts of understanding were discovered as a result of all the debates, such as the Zeeman effect.
Now the Zeeman effect was the splitting of spectral lines as the light wave came closer to magnetic fields. Each splitting of the spectral line helped scientists determine different electron movements from elliptical orbits to eventually electron spin.
I'm the dual wave particle proponent of all things.
The dual particle wave proponent of all things states that everything is both a wave and a particle. But of course large bodies seem more like particles, not waves. But small things like light can be seen as particles, photons, and waves, electromagnetic waves.
This is when the two titans of physics, Niels Bohr and Albert Einstein, went head-to-head to see who was right after all.
God does not play dice in the universe!
Quantum mechanics resolves every discrepancy that Newtonian physics ever raised.
I still don't like the fact that quantum mechanics is indeterminable. Particles can only be defined only by finding the probability of what they could be.
Einstein was a scientific realist. He believed that the laws that applied to subatomic particles were the same as those that applied to the real world. He preferred the laws he had grown accustomed to, not the strange and illogical laws that existed on a quantum level. The reason for his doubt was this philosophy, which makes understanding quantum mechanics very difficult. How can objects disappear and reappear in completely different places spontaneously? That is why Einstein had such a hard time with quantum mechanics, because the properties of quantum are completely different than those seen in everyday life.
Well, there's no better solution to all the problems classic physics faced when pushed to the extreme.
Niels Bohr, on the other hand, happily accepted and understood this theory. He believed the universe was already random and left to chance, while Albert Einstein believed the universe could be calculated with mathematics and equations. Both men were correct, but Albert Einstein was thinking in macroscopic terms, while Niels Bohr was thinking in quantum terms. So, as it turns out, Albert Einstein was wrong. Truly, it must have been hard for Niels Bohr to stand up to such an iconic figure, the very man who founded the theory of relativity. Had he not, the field of physics may not have advanced to the point where it is today. Now, how far exactly have we gotten? With our newfound knowledge, we can create and manipulate nuclear power. Using it, we can supply the world with a near infinite supply of fuel. But depending on how we use that power, we can also destroy the world. The atomic bomb, as we all well know, decided the fate of the world in World War II. And it would not have been conceived had it not been for Niels Bohr and Albert Einstein. But really, since the time of Einstein and Bohr, there haven't been many major changes. But one theory that emerged is known as the string theory. It attempts to combine quantum mechanics with other theory.
Now this entire theory was pieced together at the Copenhagen Institute, which is why it is considered the Copenhagen interpretation.
There are many different ways to interpret the theory, but the Copenhagen theory is the most widely accepted.
It was developed as a means to connect quantum mechanics with the conventional laws of the universe. But how far down the rabbit hole must we go? When will humanity's journey of understanding everything end? And most importantly, who will guide us there?